Welcome to physics. In this lesson, we are going to define what physics is and let you know why it is so important to study. First of all, take a look at this cartoon, a classic. And in this cartoon, it's showing a fundamental component of physics, and that's gravity in the motion unit. Now, it also kind of answers the question, why do I need to know this? Well, just think about it. Gravity, and I would like to say just about every physics principle, is really part of your everyday life. Now, in order to set the stage for the study of physics, what that is, study of matter and energy and motion and forces and how they all interrelate, I thought we would take a look at some key historical figures. So who we have here is Archimedes. Archimedes was a philosopher way long ago, oops, that's a D, and around 300 BCE, which is before the Common Era. And Archimedes, he broke motion down into two types. He said, well, motion can either be violent motion as a result of forces, pushes, pulls, or motion could be natural. And that would be things like rocks falling, or as this picture depicts, smoke rising. Well, now we're going to jump quite a bit of years and go to our next scientist, and that was Copernicus. So Copernicus lived around 1500, and he was very controversial at the time, and the reason being is described or shown here in this model. And this is the heliocentric model that he came up with. Helio meaning sun, centric meaning center, so sun-centered. Now, at the time, the geocentric model was widely believed. Geocentric meaning earth-centered. Geo is earth, earth-centered. But Copernicus said the heliocentric model was the valid model, that our planets revolve around the sun and the sun is the center of our solar system. Now, about 100 years later, we have Galileo. And Galileo did support Copernicus's heliocentric model. Galileo was around 1600. Galileo also went on to say that forces were only needed to keep an object moving if there were things like friction or air resistance. And what he is famous for, since he was from Pisa, Italy, was dropping cannonballs off the Leaning Tower of Pisa. Well, if we look here at this picture, I'm not quite sure those are cannonballs. They look like large boulders here. But he did drop different size objects from the Leaning Tower of Pisa and noted that they hit the ground at the same time. Regardless of their mass, they still hit the ground at the same time. Well, Galileo really did pave the way for Isaac Newton. Now, Isaac Newton, interestingly enough, he was born in 1642, the same year that Galileo died. And what he's probably best known for, Isaac Newton, are his 3 laws of motion, and we'll spend a lot of time on those, and also his findings on gravity and gravitation. Well, we've probably all heard the story. A young Isaac Newton is sitting beneath an apple tree, contemplating the mysterious universe. Suddenly, boink, an apple hits him on the head. Aha, he shouts. Or perhaps, eureka. Oh, wait a minute, that's Archimedes. Oh well, in a flash, he understands that the very same force that brought the apple crashing to the ground also keeps the moon falling toward the earth falling toward the sun, gravity. These famous scientists have all set the groundwork for our study of physics, the study of matter and energy and forces in motion, how they all interrelate. And we are going to begin our study with motion. This interesting sign has Galileo and Newton written all over it. It's showing objects, cow, rocks, all falling at the same rate, regardless of mass. Now, don't worry. No cows at all were injured in the making of this video. Now let's consider that poor cow falling off the cliff. He was accelerating. And there's different ways to show motion, acceleration, velocities, and such. And those are by graphs. Graphing is very important in physics, and here I'm showing 2 types of graphs that we're going to see. A distance time graph and a velocity time graph. Well, let's look over here first at the distance time graph and go through each step and see what the graph means. All right, let's say we're in a car and we are increasing our distance, but the slope is constant, so that means steady speed or constant speed going up. And now if we have a horizontal slope on a distance time graph, that means we might be stopped. Maybe we stop to get gas. As we're leaving the gas station, we might accelerate out, so change our slope here, and then we have to put on the brake and decelerate as we come to a stoplight. So this graph can show a whole series of motions for a car that I just described. Let's go over here next door. This is a velocity time graph. It also can show quite a bit. Now, this blue line here is representing constant acceleration. And how I know that is because the velocity is increasing. Stepping on the gas, velocity increasing, showing acceleration. This red line here is also showing acceleration, but it's not quite as great as the blue line because the slope is not as steep. Horizontal line on a velocity time graph means constant velocity, the cruise control is on. And then a negative slope shows deceleration or negative acceleration. So we will use lots of graphing in physics because they're a great measure and way to show the motion that's happening. Let's look at one more graph, and this is a distance time graph, or it's often called position time. And position and distance are the same. And it really can show what is going on. Okay? Now, this slope is a uniform slope. Uniform slope, it's not changing, so it's a constant slope. And it says here that slope equals velocity. Well, how do we really know that? Well, I'm famous for saying that units tell the story. So let's look at that. A slope on any graph is rise divided by run. And so the rise here, the unit is miles. So we have miles divided by the run is hours. So the slope gives you a miles per hour, and that is a velocity or a speed. Now down below here, we have simple equations that are basic building blocks in physics. You probably have seen these in algebra. Velocity is distance. X often stands for distance over time. So in this case, it's showing 140 miles divided by 2 is 70 miles per hour. Position is velocity times time. Or we also probably heard that as distance is rate times time. And it's showing that how you would get how many miles will travel. Now, one thing, if I could be real picky on this, is I'm also a big believer in titling a graph. And you typically title a graph whatever's on the Y versus whatever's on the X. So this graph could be titled position versus time. And then anyone looking at this graph could know right away it's a position time graph, distance time graph, and know what it's going to be about. So we are going to really use graphing as tools to understand motion and how it works. Well, as we end this lesson, we really went through a nice historical approach to the introduction to physics, a little bit on getting into motion, and we're going to center on that in the next lesson. And I thought I would leave you with a simulation to do. PhET simulations, PhET stands for Physics Education Technologies, are from the University of Colorado at Boulder. And there's one here that I will post called The Moving Man. And it's a great way to review motion, very simple, distance, time graph, velocity time graph, and looking at how they change as a man is moving along. And they're really quite interesting and a lot of fun too. We will be using these quite a bit, and I do hope you enjoy it. Remember my mantra, physics is fun. I like alliteration a lot. So physics is fun, and I do hope you believe that as well.